Mechanical engineering jobs interview questions and answers. Are you preparing for a mechanical engineering job interview? Whether you're a fresh graduate or a seasoned professional, mastering the most commonly asked questions can give you a powerful edge. In this video, we'll guide you through the top 20 mechanical engineering interview questions and provide smart, concise answers to help you succeed. 1. Tell me about yourself. I am a mechanical engineer with a strong foundation in design, thermodynamics, and manufacturing processes. I graduated with a degree in mechanical engineering and have gained experience through internships and professional roles where I worked on product development, CAD modeling, and system optimization. I'm passionate about innovation, teamwork, and problem solving. My goal is to contribute to projects that push the boundaries of efficiency and sustainability. Outside of work, I enjoy learning about emerging technologies and staying updated with industry trends. 2. Why did you choose mechanical engineering as a career? Mechanical engineering fascinated me due to its versatility and impact on daily life. From designing machines to improving energy systems, the field offers endless opportunities to innovate. I've always enjoyed working with tools, solving practical problems, and understanding how things work. Choosing mechanical engineering allowed me to turn that passion into a career where I can design, analyze, and improve mechanical systems that power industries and improve lives. It's a challenging field, but that's what makes it fulfilling and exciting. 3. What are your strengths as a mechanical engineer? My strengths include strong analytical thinking, attention to detail, and hands-on experience with design software like SolidWorks and AutoCAD. I excel at problem solving and have successfully led multiple team projects from concept to completion. My ability to adapt to new tools and technologies helps me stay ahead in this evolving industry. Additionally, I communicate effectively with cross-functional teams, ensuring collaboration between design, manufacturing, and testing departments, which is crucial in mechanical engineering environments. My focus on quality and safety further supports my effectiveness in this field. 4. What is the difference between thermodynamics and heat transfer? Thermodynamics focuses on the energy transformations and relationships between properties like temperature, pressure, and volume in a system. It deals with equilibrium states and energy conservation. Heat transfer, on the other hand, studies the movement of thermal energy due to temperature differences, through conduction, convection, or radiation. While thermodynamics tells us how much energy is involved in a process, heat transfer explains how and at what rate energy moves. Both are fundamental in designing systems like engines, HVAC, and power plants, and they often complement each other. 5. How do you stay updated with mechanical engineering trends? I stay updated by reading industry journals such as ASME Mechanical Engineering Magazine, subscribing to engineering YouTube channels, and following LinkedIn groups focused on mechanical innovations. I also take online courses to learn new software and tools, attend webinars, and participate in engineering forums. Networking with other professionals allows me to exchange insights and learn from real-world applications. Continuous learning is essential in this field, as advancements in materials, automation, and design technologies are constantly reshaping how mechanical systems are engineered and maintained. 6. What software are you proficient in? I am proficient in CAD software such as SolidWorks, AutoCAD, and CATIA for 2D and 3D modeling. For analysis, I use ANSYS for finite element analysis and MATLAB for simulations and data processing. I've also worked with PTC Creo and Fusion 360. My familiarity with MS Excel and engineering-specific tools helps in creating engineering reports and performance tracking. I continually practice and improve my software skills through project work, tutorials, and certifications, ensuring I remain efficient and productive in design and analysis tasks. 7. Describe a time you solved a complex mechanical problem. In my previous role, a cooling system consistently overheated, affecting performance. I analyzed the system layout, reviewed heat load calculations, and discovered inadequate airflow as the main issue. By redesigning the duct layout and increasing fan efficiency, I reduced operating temperature by 20%. I used SolidWorks to model changes in ANSYS for airflow simulation. My solution not only solved the overheating but also improved energy efficiency. This experience strengthened my diagnostic and analytical skills, which are essential in mechanical engineering problem solving. 8. What is the importance of tolerance in engineering design? Tolerance defines the allowable variation in a part's dimensions, ensuring components fit and function properly despite manufacturing inconsistencies. It balances precision with cost, allowing mass production without sacrificing performance. Too tight a tolerance increases manufacturing costs, while too loose may lead to failures. Engineers use tolerances in drawings to communicate acceptable limits to machinists. Proper tolerance application ensures quality, reduces material waste, and prevents costly rework or assembly issues. It's a critical factor in mechanical design, especially in automotive, aerospace, and machinery manufacturing. 9. How do you prioritize multiple engineering projects? I begin by assessing each project's deadlines, complexity, and impact. I use tools like Gantt charts or Trello boards to visually map tasks and timelines. Urgent or critical tasks get immediate attention, while others are scheduled efficiently. I communicate regularly with team members and stakeholders to manage expectations. Delegation, time blocking, and daily checklists help me stay organized and focused. Prioritization is not only about deadlines but also about strategic alignment, ensuring the most valuable projects receive the right resources and attention. 10. What is the first law of thermodynamics? The first law of thermodynamics, also known as the law of energy conservation, states that energy cannot be created or destroyed, only converted from one form to another. In a closed system, the total energy remains constant. For mechanical engineers, this law is crucial when analyzing engines, turbines, or HVAC systems. For example, in internal combustion engines, chemical energy in fuel is transformed into heat in mechanical work. Understanding this law helps engineers design efficient systems by accounting for energy inputs and outputs correctly. 11. How do you ensure the safety of mechanical systems? Safety begins with proper design, ensuring components are rated for their loads and stresses. I use FEA software to simulate stress and thermal behavior. I also follow industry standards like ASME, ISO, and OSHA regulations. During manufacturing and assembly, I inspect for quality and material integrity. I develop maintenance schedules and operating manuals to reduce wear and tear. Additionally, I implement fail-safes and conduct risk assessments. Communication with operations teams is essential to understand on-the-ground concerns and continuously improve safety practices. 12. What is preventive maintenance and why is it important? Preventive maintenance involves regularly scheduled inspections and servicing to prevent mechanical failure before it occurs. It includes tasks like lubrication, part replacement, alignment checks, and cleaning. This approach increases equipment life, reduces unexpected downtimes, and lowers repair costs. For critical machinery, preventive maintenance ensures continuous operation, especially in manufacturing or energy plants. It also improves safety by identifying potential hazards early. I use maintenance logs and CMMS software to track schedules and performance, making preventive maintenance both systematic and data-driven. 13. How do you handle project deadlines under pressure? When under pressure, I break projects into smaller, manageable tasks with realistic timelines. I prioritize based on urgency and impact. Communication is key. I keep stakeholders informed and set clear expectations. I eliminate distractions, delegate when appropriate, and work extra hours if necessary. Stress management through structured planning helps me stay focused and effective. I also reflect on past time management lessons to improve efficiency. Meeting deadlines while maintaining quality is a challenge I enjoy, as it sharpens my problem-solving and leadership skills. 14. Describe the working principle of a centrifugal pump. A centrifugal pump works by converting rotational kinetic energy into hydrodynamic energy. When the impeller spins, it imparts velocity to the fluid. This velocity is then converted into pressure as the fluid exits through the volute casing. The centrifugal force generated moves the fluid outward from the center to the discharge port. These pumps are widely used in water treatment, HVAC, and industrial applications for their efficiency and reliability. Understanding the working principle helps engineers choose the right pump based on fluid type, flow rate, and head requirements. 15. What is the purpose of a pressure relief valve? A pressure relief valve is a safety device designed to release excess pressure from a system to prevent equipment damage or explosions. When pressure exceeds a preset limit, the valve opens, allowing fluid or gas to escape, and then reseals when safe pressure is restored. It's commonly used in boilers, pipelines, and compressed gas systems. By maintaining pressure within safe limits, these valves protect both equipment and personnel. As a mechanical engineer, I ensure proper sizing, selection, and testing of relief valves during system design. 16. How do you conduct failure analysis? Failure analysis starts with identifying symptoms, vibration, noise, leaks, or physical damage. I collect data on operating conditions and examine failed parts visually and using tools like microscopes or scanners. I check for fatigue, corrosion, wear, or material defects. Analytical tools like root cause analysis, RCA, FMEA, or fault tree analysis help pinpoint the issue. I also compare results with design specs and test data. Based on findings, I suggest design modifications, better materials, or maintenance changes. The goal is to prevent recurrence and improve system reliability. 17. What is the difference between static and dynamic loading? Static loading refers to forces that are applied slowly and remain constant over time, such as the weight of a building on its foundation. Dynamic loading involves forces that change rapidly, such as vibrations, impacts, or cyclic loads. Mechanical systems must be designed differently depending on the type of load. Dynamic loads introduce complexities like fatigue, resonance, and stress concentration. Engineers must analyze both types carefully during design to ensure safety and durability, especially in machinery, vehicles, and structural applications subject to changing or shock loads. 18. Why is material selection important in mechanical design? Material selection impacts a product's strength, durability, weight, cost, and performance. Using the wrong material can lead to premature failure or excessive costs. Engineers consider properties like tensile strength, hardness, corrosion resistance, and thermal conductivity when choosing materials. Application-specific needs, such as biocompatibility or heat resistance, also influence choices. I refer to material data sheets, conduct mechanical testing, and apply design standards to ensure optimal material use. Correct selection not only improves function and longevity but also aligns with sustainability and manufacturing capabilities. 19. How do you handle design revisions from clients? I start by understanding the rationale behind the client's revision. I ask clarifying questions to ensure alignment on expectations. Then, I assess how the changes affect the overall design, cost, and timeline. I document the revisions, update CAD models, and revalidate the design through simulations or calculations. Communication is key. I keep clients informed on progress and limitations. I view revisions as a collaborative process that leads to better results, and I maintain a professional, solution-oriented attitude even when faced with challenging requests. 20. Why should we hire you as a mechanical engineer? You should hire me because I bring a blend of technical expertise, hands-on experience, and a strong work ethic. I am proficient in industry-standard tools, dedicated to safety and quality, and have a proven record of delivering engineering solutions under pressure. My ability to adapt quickly, learn continuously, and communicate clearly makes me a valuable team member. I'm not just looking for a job. I'm looking to contribute to meaningful projects, grow with the company, and help solve engineering challenges efficiently and creatively. Thank you for watching. We hope these top 20 mechanical engineering interview questions and answers help you feel more confident and prepared. Don't forget to like, share, and subscribe for more career-focused content. Best of luck in your interview journey.